My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Object-Oriented System Development as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: why we need architecture? In object-oriented system development, we need software architecture because it acts like a blueprint for the entire system. Architecture defines the high-level structure, components, and their interactions, helping developers understand and manage complexity. Simple meaning: think of architecture like building a house. Before constructing, you need a plan showing rooms, doors, electrical wiring, and plumbing. Without a plan, the house may be unstable or chaotic. Similarly, software architecture guides the development to avoid confusion, delays, or errors. Why architecture is needed? 1. Organizes the system, shows how modules and components interact. 2. Improves maintainability, makes it easier to fix bugs and add new features. 3. Enhances scalability, helps the system grow without breaking existing parts. 4. Facilitates communication, stakeholders and developers understand the system clearly. Example: in an online shopping system, architecture defines how the user interface, shopping cart, payment gateway, and database interact. Without proper architecture, developers might create disconnected modules, making the system unreliable. Easy trick to remember: architecture is equal to blueprint of software. It ensures the system is organized, scalable, and maintainable, just like a well-planned building. Next unit 4. Long questions. First important long question is: discuss about unified software development process. In object-oriented system development, the Unified Software Development Process (USDP) is a structured approach to develop software using object-oriented concepts. It is also called the Rational Unified Process (RUP). USDP helps in organizing the development life cycle into clear phases and ensures high-quality, maintainable software. Simple meaning: think of USDP as a roadmap for building software. Just like constructing a building requires planning, designing, constructing, and testing, software development also needs a step-by-step approach. USDP provides this roadmap with iterative improvements. Key phases of USDP. 1. Inception phase: identify requirements and scope of the system. Example: for an online shopping system, decide the features like product catalog, checkout, and payment. 2. Elaboration phase: design architecture and key components, addressing risks. Example: decide how shopping cart, payment gateway, and database will interact. 3. Construction phase: develop the actual system by coding modules. Example: implement classes and modules for user interface, payment, and order processing. 4. Transition phase: deploy the system to users, fix remaining bugs, and train users. Example: launch the online store and ensure users can place orders without issues. Key features of USDP. Iterative development: software is built in small, manageable iterations, not all at once. Use case driven: requirements are captured using use case diagrams to understand user interactions. Architecture centric: focuses on designing a strong software architecture from the start. Risk focused: identifies and manages potential risks early. Easy trick to remember: USDP is equal to plan, design, build, deploy, step by step with iterations. It's like building a house floor by floor, checking quality at each stage, instead of trying to build it all at once. OOSD ensures organized, reliable, and high-quality software development, especially for complex object-oriented systems, making it easier for developers and stakeholders to collaborate and deliver successful projects. Next important long question is to explain about unified process in detail. In object-oriented system development, the unified process, UP, is a structured methodology for building software using object-oriented techniques. It is an iterative and incremental approach that ensures software is well-planned, robust, and adaptable. The unified process is also called the rational unified process, RUP. Simple meaning. Think of UP like building a house step by step. You first plan, then design, then construct, and finally hand over the house. Similarly, in software, UP divides the development process into phases with repeated iterations, so improvements can be made at each step. Phases of unified process. 1. Inception phase. Understand what the system should do and its scope. Example, in an online shopping system, decide features like product catalog, checkout, and payment options. Goal, identify major requirements and feasibility. 2. Elaboration phase. Design the system architecture and handle risks. Example, plan how shopping cart, payment gateway, and database interact. Goal, ensure the architecture is strong and risks are minimized. 3. Construction phase. Develop the software components iteratively. Example, code modules for product browsing, cart management, and payment processing. Goal, build the system step by step with tested components. 4. Transition phase. Deploy the system to users and fix remaining issues. Example, launch the online store and ensure users can place orders smoothly. Goal, make the system operational for real users. Key features of unified process. Iterative and incremental. Development occurs in small cycles, improving quality at each step. Use case driven. System requirements are captured using use case diagrams. Architecture centric. Focus on strong software architecture from the beginning. Risk focused. Potential risks are identified and handled early. Easy trick to remember. UP is equal to inception, elaboration, construction, transition, step by step. Think of it as building a floor at a time, checking quality, and making improvements, rather than constructing the whole house at once. The unified process ensures software is organized, maintainable, and adaptable, making it ideal for complex object-oriented systems like online shopping platforms, banking systems, or enterprise applications. Next important long question is 3. Illustrate 4 Ps in software development. In object-oriented system development, the 4 Ps of software development are people, process, product, and project. These 4 elements are key factors for successful software development. Understanding them helps plan, organize, and execute software projects efficiently. 1. People. People include developers, testers, analysts, project managers, and stakeholders who contribute to software development. Importance: skilled people are essential for high-quality software. Example, in an online shopping system, developers write code, testers check the system, and managers coordinate tasks. 2. Process. Process is the methodology or approach used to develop software, like the unified process, UP, Agile, or Waterfall. Importance: a structured process ensures the project is organized, trackable, and less error-prone. Example, using the unified process, the online shopping system is developed in inception, elaboration, construction, and transition phases iteratively. 3. Product. Product refers to the software application or system being developed, including its features, functionality, and performance. Importance: the product is the end result that meets user requirements. Example: the online shopping system is the product that allows customers to browse items, place orders, and make payments. 4. Project. Project represents the effort, time, and resources used to develop the software. It includes planning, scheduling, budgeting, and monitoring progress. Importance: a well-managed project ensures timely delivery and cost efficiency. Example: developing the online shopping system is a project with tasks like coding, testing, and deployment assigned to team members over a fixed timeline. Easy trick to remember. Think of 4 Ps as the building blocks of software success. People is equal to builders. Process is equal to blueprint. Product is equal to house. Project is equal to construction plan and schedule. Conclusion: the 4 Ps work together. People follow a process to create a product within a project framework. Neglecting any one of these can lead to delays, errors, or a poor quality system. By balancing all 4, software development becomes organized, predictable, and successful, especially for complex object-oriented systems like online shopping platforms, banking systems, or enterprise software. This framework is easy to remember, practical, and widely used in software engineering. Next important long question is: 4. Write short note on use case driven process with an example. In object-oriented system development, a use case driven process is a development approach where use cases guide the entire software development life cycle. It ensures that the system is designed from the user's perspective, focusing on what the system should do rather than how it is implemented. Simple meaning: think of it as building software based on real user interactions. A use case is like a story describing how a user interacts with the system to achieve a goal. By using these stories, developers can design, implement, and test software that truly meets user needs. Key features: 1. User-centric. The development starts with understanding user requirements. 2. Requirement clarity. Use cases clearly describe functional requirements. 3. Guides design and testing. Each use case can be translated into class diagrams, sequence diagrams, and test cases. 4. Supports iterative development. Use cases can be implemented in small iterations, improving flexibility. Example: consider an online shopping system. A use case might be place an order. Actor: customer. Goal: complete a purchase of products. Steps in use case: 1. Customer selects products. 2. Adds them to the shopping cart. 3. Enters shipping and payment details. 4. Confirms order. 5. Receives order confirmation. From this use case, developers can create class diagrams for shopping cart, order, payment gateway. Design sequence diagrams showing interactions between the customer, cart, and payment module. Write test cases to verify that the ordering process works correctly. Benefits of use case driven process: 1. Ensures software matches user expectations. 2. Improves communication between developers and stakeholders. 3. Reduces misunderstandings and errors. 4. Provides a clear roadmap for design, implementation, and testing. Easy trick to remember: use cases is equal to user stories guide design, coding, and testing. By following a use case driven process, software development becomes structured, user-focused, and reliable, especially for object-oriented systems like online shopping platforms, banking applications, and enterprise software. It's a practical and effective approach widely used in the Unified Software Development Process (USDP). Next important long question is 5. Briefly explain about architecture process in brief. In object-oriented system development, the architecture process is a systematic approach to design the high-level structure of a software system. It defines the major components, their responsibilities, interactions, and deployment, ensuring the system is organized, scalable, and maintainable. Simple meaning. Think of the architecture process as planning the skeleton and blueprint of a building before construction. Without a clear architecture, software may become messy, hard to maintain, or fail under high load. Steps in the architecture process. 1. Identify system requirements, understand functional and non-functional requirements. Example, in an online shopping system, requirements include browsing products, placing orders, secure payments, and fast response time. 2. Design high-level components, break the system into major modules and define responsibilities. Example, modules can include user interface, shopping cart, payment gateway, order management, and database. 3. Define interactions, specify how components communicate and exchange data. Example, shopping cart interacts with order management and payment gateway for completing an order. 4. Choose architectural style, decide the overall structure like layered, client-server, or microservices architecture. Example, the online shopping system can use client-server architecture where clients access the system via a web browser and servers handle processing. 5. Plan deployment, determine where components will run on physical hardware or cloud servers. Example, web server hosts user interface, application server hosts business logic, database server stores order data. 6. Review and validate, check if the architecture meets requirements, performance, and scalability goals. Benefits of architecture process. 1. Provides a clear roadmap for developers. 2. Ensures modularity and scalability. 3. Helps manage risks by addressing major issues early. 4. Facilitates communication among developers, managers, and stakeholders. Easy trick to remember. Architecture process is equal to blueprint of software plus roadmap for building it. Just like a building needs a solid blueprint, software needs a well-thought-out architecture to be reliable, maintainable, and scalable. By following the architecture process, developers can ensure complex object-oriented systems like online shopping platforms, banking applications, or enterprise systems are efficient, robust, and easy to maintain. Next important long question is 6. Explain about iterative and incremental process. In object-oriented system development, the iterative and incremental process is a software development approach where the system is built step by step, incremental, and improved through repeated cycles, iterative. This approach is widely used in the Unified Software Development Process (USDP) route because it reduces risks, improves quality, and adapts to changing requirements. Simple meaning. Think of it like building a Lego model. You don't build it all at once. Instead, you assemble small sections, increments, check if they fit correctly, and then add more pieces, iterations, until the complete model is ready. Key features. 1. Iterative. Software is developed in repeated cycles, allowing developers to review and improve the system at each stage. 2. Incremental. The system is built in small parts, called increments, which are individually developed, tested, and delivered. 3. Early feedback. Users can see and test partial systems, providing feedback for the next iteration. 4. Risk management. Problems are identified early, reducing the chances of major failures later. Example. Consider an online shopping system. 1. First increment, build a simple product catalog so users can browse items. 2. Second increment, add shopping cart functionality to select products. 3. Third increment, integrate payment gateway to allow order processing. 4. Fourth increment, add order tracking and notifications. After each increment, the system is reviewed and improved. If any issues are found, they are fixed in the next iteration. Benefits. 1. Reduces project risks by addressing problems early. 2. Delivers functional software faster, even if the full system is not complete. 3. Easier to handle changes in requirements. 4. Improves quality through continuous testing and feedback. Easy trick to remember. Iterative is equal to repeat and improve. Incremental is equal to build small parts step by step. By using the iterative and incremental process, developers can create complex object-oriented systems like online shopping platforms, banking applications, or enterprise software in a structured, flexible, and high-quality way. It's like building a house floor by floor, checking each floor before adding the next.